I am an IIT faculty for many years and also an ex-senior physics professor of number one IIT institute in India. In my long career, I have seen that the students need guidance in very small concepts. They go through various concepts, but they are not clear about those concepts. So that's why I am making this type of videos, and I will be making this series of videos. And if you are benefited by these videos, then please like these videos and share this video as much as you can. And also, since I will be making this type of videos regularly for the benefit of students, please subscribe to my channel and press the bell icon so that you can get notification of any video whenever it is coming. I also want you to comment on the video so that I can get whether you want any further clarification or you want any other topic to be discussed. I will discuss that. Now today's topic is a very important topic. See, circular motion, you have some ideas. You know that circular motion has velocity. It has an acceleration called centripetal acceleration towards the center. But today I will discuss about the vector treatment of the circular motion. So let me start. So my today's topic is circular motion and vector treatment of it. Now look at the diagram. Let a point P is moving in a circle about center O, and we call O as origin, and we draw two mutually perpendicular lines AOB and DOC and call them as x-axis and y-axis. And we call the position vector of O from of P from O as R vector. So R vector is nothing but OP vector. It has magnitude R and it has a direction from center to point P. Now, if it has started from B and going along the circle, then if its angular velocity is a constant omega, so in time t it will cover an angle of theta, and theta is given by POB here. This theta we can write as omega into t because that is the angular displacement. So in that case the particle has the position vector as r, which has two components along x-axis and y-axis. The x-axis component is r cos theta I cap and y-axis component is r sin theta j cap. And we can write r vector as r cos theta I cap plus r sin theta j cap, which becomes actually r cos omega t I cap plus r sin omega t I cap because theta is omega t. And unit vector r cap becomes therefore r vector divided by its magnitude r. That means unit vector r cap becomes cos omega t I cap plus sin omega t j cap. This is from the previous equation. Now, if we have to find velocity, velocity is nothing but rate of change of the position. That means dr by dt. And we take r as vector. That means if we differentiate the earlier equation, means r equal to r omega t I cap plus r equal to plus r sin omega t j cap. That means r equal to r cos omega t I cap plus r sin omega t j cap. If we differentiate it with respect to t, we get v equal to dr by dt equal to r into minus sin theta d theta dt plus cos theta into d theta dt minus sin theta d theta dt I cap plus cos theta into d theta by dt j cap, because differentiation of cos theta becomes minus sin theta, differentiation of sin theta becomes plus cos theta. Now d theta by dt is nothing but omega. Therefore v vector becomes, and if we take them as omega and take common, v vector becomes r omega into minus sin theta I cap plus cos theta j cap. That means v has a magnitude r omega and it is along the tangent. That we already know. It is coming from vector. Now if we can again differentiate it, we will get acceleration, a equal to dv by dt. That means if we differentiate the above expression of v, we get r omega into, if we differentiate sin theta, we get cos theta. So r omega into minus cos theta d theta by dt into I cap. And if we differentiate cos theta, we get minus sin theta. So it becomes minus cos theta d theta dt I cap minus sin theta d theta by dt j cap. Or if we take common, if we write d theta by dt as omega and if we take common, we get minus r omega square into cos theta I cap plus sin theta j cap. That means the acceleration has a magnitude omega square r, and the unit vector is same as r, because unit vector of r was cos omega t I cap plus sin omega t j cap. Here also we get cos omega t I cap plus sin omega t j cap, or cos theta I cap plus sin theta j cap. Now there is a negative sign also. That means the magnitude of the acceleration is omega square r, which ultimately becomes v square by r, and it has a direction along the radius but opposite to r. Opposite to r means it is towards the center, and this is what is centripetal acceleration. So we take a vector representation of position vector, we differentiate it to get the velocity vector, we differentiate it further to get acceleration vector, and the velocity vector we find having a magnitude r omega and it is tangential. Acceleration vector we find having a magnitude omega square r and it is along the radius and towards the center, and this is called centripetal acceleration. So this was the topic today. I hope you have understood, and it is a very important topic because in physics, particularly for JEE Advanced, everything we have to do by vector, and that is the easiest way to deal with physics problems in JEE Advanced. So please listen to this video again and again, and if necessary note down so that you can get the full benefit out of it. So this much today. Thank you very much.